Welcome to Brunda Engineering Academy. In this video, we discussed about the topic, a new subject. It is engineering materials. Engineering materials. This concept discussed based on the ECET syllabus, and GATE syllabus point of view. GATE syllabus point of view, we will discuss about this concept. As per the subject, these mechanical properties, the concept is mechanical properties. It can be used in the both subjects, engineering materials, and at the same time, strength of materials. Strength of materials. Strength of materials. This can be common topic for the both civil and mechanical engineers. Mechanical engineers, both civil and mechanical engineers. So now, in this video, let us know about the mechanical properties of the materials. First of all, these materials can be classified into two ways. Materials can be classified into two ways. One is metals. One is the metals. Another one is non-metals. 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 Metals and non-metals. Okay, in the metals, again, we have two categories. One is the ferrous materials. Ferrous means here iron materials, iron metals, whereas non-ferrous materials, non-ferrous. These are the common thing I think you know about that. Ferrous metals and non-ferrous metals. Whereas coming to the non-metals point of view, we have organic materials, organic organic materials, and another one is the ceramic materials, organic and ceramic materials. In the organic materials, again, we have the two different categories that will be discussed later. Now, in this video, we have to discuss about the mechanical properties of the materials. The first property is the strength of the material. Strength of the material means the ability of material to resist the loads, the ability of material to resist the loads without failure. Suppose I am considering a body. We apply the force on this body, in this way. Okay. Then if you apply the loads on the body, it can be resist that loads without failure. There is no damage in the body. Okay. That resistance is called as the strength of that material. The strength may be here three ways. One is the tensile strength. Second one is the compression strength, and maybe shear strength. That will be depends upon the type of applying loads. If you apply the tensile loads, if you apply the compression loads, if you apply the shear loads, we can calculate the tensile strength, compression strength, shear strength like this. Finally, the definition point of view, the ability of the material to resist the loads without failure is the strength of that material. Whereas the next property is the stiffness of the material. Stiffness means suppose again I am considering a body. If you apply the force on the body, initially the length of the body is the 5 meters. If you apply the force, then definitely it can be deformed. That means the length may be changed. The length may be increased to 2 meters. That means totally 7 meters may be varies. That means the deformation will be there. Okay, the ability of the material to resist that deformation, under load is called as stiffness of the material. If you apply any load on the body, then definitely some effect will be causes. So to resist that deformation, that property is called as the stiffness of that material. Okay, that stiffness of the material is measured by the modulus of elasticity. The stiffness of the material can be measured by the modulus of elasticity. Modulus of elasticity is nothing but the ratio between stress and strain. The ratio between stress and strain is called as the modulus of elasticity. That is capital E equal to sigma by E. That means stress by strain. That is about the property of stiffness of the material. Next, an important property, that is elasticity of the material. Elasticity of the material means if you apply the force on the body, then initially, if you apply the force on the body, after applying the if you apply the force on the body, then it will be deformed. Okay. After removal of that force, again it will be comes into its original condition. For example, initially that is a 3 meters length. The body is having 3 meters length. After applying the force, it may be 5 meters length. After removal of that forces, again it will be coming to the 3 meters of length. That property is called as the elasticity of the material. The definition, the ability of the material to deform under load and return to its original condition. When the load is removed, after removal of the load, the body is coming into the original condition. That is called as the elasticity. If the body is not coming into the original condition, that property is called as the plasticity. The body is coming into the original condition, that is called as the elasticity. If not coming into the original condition, that property is called as the plasticity of the material. Next, next property is the ductility of the material. It is a very important property. Ductility means here the ability of the material to be deformed plastically. Means the body will be deforms plastically. Plastically means the body cannot be regain its original condition. So that property, the ability of the material to be deformed plastically without rupture. Without rupture is nothing but without failure. Without failure in the body under tensile load. It is very, very important. If again I'm considering the body, if you apply the force, tensile load, it can be elongated. Elongated means it can be deformed, but it cannot be regain its original condition. Original condition means plastic deformation without any failure. Suppose if you observe the gold ornament or rings or gold chains, the tensile loads will be applied on the body. It cannot be failure. Okay. Finally you have to remember ductility means the ability of the material to be deformed plastically without failure under tensile load. That is called as the ductility. Whereas another similar property is there, that is malleability. The same condition, here we are applying the load of compressive loads, compression loads. The ability of the material to be deformed plastically without rupture under compressive loads. If the load is the tensile load, that is the ductility. If the load is the compressive load, that is called as the malleability. Okay. Here, one more important concept in the competitive point of view. Materials which are highly ductile are also highly malleable. But the reverse may not be true. Okay, that means if the material are having high ductility, then definitely that is having high malleability. Whereas if the material is high malleability, but that may not be highly ductile. Next important property is the toughness of the material. Toughness of the material means suppose you are sitting on a chair. Your load is having a 70 kgs. That 70 kgs will be absorbed by the chair, and that chair cannot be deformed. Okay, that chair cannot be failure. So that ability is called as the toughness of the material. Is as per the definition point of view, the ability of the material to absorb the energy. That means our weight will be absorbed by that chair. The ability of the material to absorb the energy up to the fracture during the plastic deformation is called as the toughness of the material. Important concept is toughness depends upon the strength and ductility of the material. Toughness of the material will be depends upon the strength and toughness of the strength and ductility of the material. Toughness can be depends upon the strength and ductility of the material. Next, modulus of here. So so these are the some important properties of the materials. In the next video, we will discuss about the remaining properties of the materials. Please like, share and subscribe Brunda Engineering Academy.